Welcome to qnawire.
Hi, so for this question, in the first part, we need to calculate the pH of a buffer solution that has the same concentration, 0.453 molar, of an carboxylic acid and its conjugate base of CH3COO minus. So the pH for this is going to be equal to the pKa plus the logarithm of the concentrations. I'm going to simplify this as A minus and HA. But since we know that the concentrations are the same, this logarithm is equal to 0 because this is logarithm of 1. So the pH is directly equal to the pKa. And we're told that the Ka is equal to 1.8 times 10 to the minus 5. So this pKa is equal to minus the logarithm of Ka. And the result is 4.7447 that you can round it up as 4.745 or 4.74 depending on how many significant figures are asked in the platform that you're using. If they ask for 3, use 4.745, and if they ask for 2, you can use 4.74 directly. And for the second part of this question, we need to write down the net ionic equation for the reaction that occurs when 0.122 mole of HI is added to 1 liter of the buffer solution. So the net ionic equation that is going to happen, first of all, let's remember that Hi in water is going to produce H3O plus I minus. So that means that the actual thing that is happening is that the conjugate base is going to react with H3O plus in order to generate the carboxylic acid plus water. And actually, over here, we can go ahead and do the calculation using our ice table. We are told that we are in 1 liter of solution, so the initial concentrations are going to be the same, 453, 0.453. And if we added 0.122 mole directly, assuming that you haven't changed the volume of the solution, what we can say is that we added 0.122. And water is not going to matter because it's a pure substance. The limiting reagent is going to be the acid that we added to the solution. And at equilibrium, we're going to have 0.331, 0, and 0.575. That means that we're going to have more acid than the conjugate base, thus the pH is going to be lower than the pK. And you can verify it by plugging in to the Henderson-Hasselbalch equation. Plus, in this case, the logarithm becomes 0.331 over 0.575, giving a pH equal to 4.5. So the net ionic equation that you're going to actually answer here is this one. And if they ask you later to calculate the pH, that's how you do it. And that would be all. Thank you very much.